We'll take a quick tour of 202R030. It has 3 mechanical modules and 3 auxiliary modules that include a water-to-water heat exchanger. We'll take a tour of the water-to-water heat exchanger path. The orange lines here represent the comfort cooling loop, providing 42-degree water. The red line is the space loop, 55-degree water coming back from the space, being cooled to 45. Green is the pump discharge. The blue line is the water that is supplying to the space, so 45-degree water going to the space. Now we'll do a close-up of the bypass valves, the 2-position valves that control the heat exchanger. So those 3 valves are on the comfort side of the loop. This is the normal mode, 42-degree water going through the heat exchanger. When the water rises above 45 degrees, we open the bypass path. 55-degree water coming back through its strainer, through its tank, and then through the heat exchanger, and then over to the pump suction. The green line in the distance is the discharge from the pumps, providing water to the upper header in the mechanical modules. The blue line represents the leaving water from the lower header and ultimately out of the array. Control panel at the top of this module is for the heat exchanger, and now we'll swing around to the space entering connection through its dual basket strainer and ultimately to the storage tank. Again, through the strainer into the storage tank, and leaves the bottom of the storage tank to pass through the heat exchanger. There are manual isolation valves for the tank and manual isolation and bypass valves on the space side of the heat exchanger. Water flows from right to left in this picture over into the pump suction. One more shot of the heat exchanger. Right side of the heat exchanger with the 2-position automated valves is the comfort loop side. This is the side with the colder water, generally 42-52. The left-hand side is the space being served side of the heat exchanger with the manual valves, generally 55-45. In the next frame, we've moved inside the service walkway, and we're looking at the space heat exchanger into the storage tank, and then leaving the storage tank heading toward the heat exchanger. Again, we're standing between the auxiliary modules and the mechanical modules on a service walkway. We've paused here to see the manual isolation and bypass valves on the space side of the heat exchanger. And now we'll work our way left into the pump module. So working right to left, we have water that's leaving the heat exchanger that has either been cooled if we're in normal mode, or has not yet been cooled if the comfort loop is in bypass. We're going into the suction side of the pumps, and then we'll move vertically up into the discharge and come down into the top header of the master mechanical module. Again, the vertical discharge from the pumps, the check valve, where they tee together and then turn down to enter the master mechanical module here. The 3 mechanical modules are independent circuit modules and also have low ambient, so there's a receiver for each circuit. We use a dual circuit evaporator similar to our water-cooled modules, so there are 2 inlets and 2 outlets for refrigerant and 1 inlet and 1 outlet for chilled water in each of the 3 evaporators. We have manual isolation valves between the top and bottom headers and the top and bottom connections for each evaporator. And now we'll move in and get a closer view of the components in the lower side of the mechanical module. We see our 2 compressors, again, independently circuited to the condenser and independently circuited to the evaporator. Moving to the right, we'll see the first receiver, liquid line solenoid valve in the background on the right, expansion valve for the first circuit, the evaporator with the manual isolation valves on the top and bottom header, and then we'll move around and see the second receiver. We see the two high pressure switches in the background, the piping coming down from the condenser. And we freeze on the liquid line solenoid valve and the expansion valve. We continue the tour panning up. On the left we have the single point power junction box, and on the right the Hoffman box for the C1 panel. Moving into the single point power junction box, we see the door interlock disconnect switch, the electrical ratings stickers in the junction box, the 225 amp single point power door interlock disconnect switch / circuit breaker, moving into the power distribution block, and the 6 circuit breakers that feed the 3 mechanical modules, the pump module, the heat exchanger, and the C1 panel. And now we'll have a series of photos of the various components. So the top 3 breakers, and now back into the junction box, panning down. And now we'll have a picture of the lower 3 breakers in the junction box. Now we'll move out of the junction box and swing to the left to see the Hoffman box that is referred to as the C1 panel. This is the interface to the remote panel, which we'll see in a minute. The lower portion of the box has the remote local switch on the right-hand side, and in the lower left corner you see the interface, the blue interface for the convenience outlet. Panning up, we see the transformer that serves the convenience outlet and the control relays. Here's a close-up of the convenience outlet transformer. So again, on the right, the single point power junction box, 2 mechanical modules. This bypass line shown here is actually going to be moved to the opposite end of the chiller before it ships, and we'll explain that at the end of the video. Now we're moving in for a close-up of the remote panel. It has both the remote display and indicator lights and control switches. This is the inside of the remote panel. Again, it interfaces with the C1 that hangs on the back of the chiller adjacent to the junction box for single point power. And now we'll take a tour of the outside of the mechanical modules. You'll notice a couple of things, not only the independent circuits that were mentioned before, but because of the independent circuits, we don't have electronic expansion valves. We have traditional expansion valves as part of this chiller configuration. Working right to left, power comes in, distributes through the circuit breakers, through the compressor contactors, gray CC1 and CC2. Working our way to the right, we have the manual off-auto switch and the control power transformer, and our slave controller in each mechanical module. The master module has 2 Corel controllers. And now down into the lower portion, we have 2 sets of gauges there, again because of independent circuits. Working our way right to left, our 2 compressors. Again, we have 2 receivers, and here's a close-up of the receiver. And the filter dryer, we have 2 receivers because of independent circuits in this particular configuration. We're going to pan up and see the ECM fans that are part of this configuration. A little bit more airflow and a little bit quieter airflow. Now we'll take a close-up of the pump module from the front side. We move through and see the control panel with the relays, lead lag toggle switch, contactors, and circuit breakers. Move down right to left, and we'll break this down with a colored tour of the piping. The red lines are the space water coming from the tank through the heat exchanger and to the pump suction. The green lines are the discharge serving the upper header. The blue line is the lower header, which is the leaving chilled water going out to serve the space. Working our way around, we'll then see the expansion tank and the glycol mini feeder that sit above the pumps. As we mentioned earlier, we're going to change the configuration of the bypass valve. This is the current configuration, wrapping around the mechanical modules and then into the tank. And this is to balance the system, so that if we have a little bit too much water heading toward the system, we can open a balancing valve and bypass water back to the storage tank from the leaving connection. Here's the existing leaving connection. We're going to take this spool piece that's been colored in gray and the balancing valve, take those two components and move it to the opposite end of the chiller. It's currently at the mechanical module end of the chiller under the junction boxes, and we're going to move it to the other end of the chiller where we have both a leaving connection shown here in the lower right and then the entering connection in the upper left. So you can see the gray spool piece drawn in there, that's where it will be placed, and the blue line and the drawn in balancing valve will be the connection, so allowing us to bypass water from the lower leaving connection back into the entering connection if we have an excess of water going out to the system. And that concludes our tour.